What's going on, guys? In this video we are going to see how to do the proof for there exists type of statements. Here we have the statement that says for all x belongs to 0 to 0, 1 there exists a y belongs to 0, 1 such that x is less than y. Okay, so let's go ahead and get a general idea for this one. For example, we have 0 and 1. Okay, here what it says is we have an x somewhere here, and it says that there's a y also here, that y is bigger than this x. So y is bigger than this, it should be somewhere here. So if you want to prove this one, like what value you can take that is greater than x and less than 1, how you can do that? If you take the average of this one, that's going to be between that, right? So that's what we are going to do. We are going to say y is equal to x plus 1 divided by 2. If you take that one, that should be somewhere here. So we want to prove this, we just have to prove this one. The y is somewhere here. Okay, in order to prove this one, first we are going to start with, let's prove x is less than 1. X is less than 1 first, because we have to prove x is greater than 0 and less than 1. So first, if x is less than 1, then x plus x must be less than x plus 1. This is by axiom number 12. Axiom number 12 says if you have x less than 1, if you add whatever the value to this one to both sides, it still should be the same. Okay, still should be less than the other one. So this is the axiom number 12, and if you want to know all the axioms, I have made a video on that. I put the link of the video in the description, so you can go ahead and watch them. So here we have x plus x, that is less than x plus 1, and we know that x plus x is 2x. 2x is less than x plus 1, and also we know that 2 inverse is greater than 0. So now we are going to use the axiom number 13. Axiom number 13 is I write the general pattern, like always we have to the easy way is you put the less than first. So less 1 first. So here we have 0. 0 is less than 2 power minus 1. And also here we have 2x, that is less than x plus 1. And what you do is you cross multiply like this. So 2x times 2 minus 1. 2 power minus 1 times 2x should be less than this multiplication, 2 inverse x plus 1. So this is the axiom number 13 says. Okay, so by that we will get here 2 inverse 2x is less than 2 inverse x plus 1 by axiom number 13. Axiom number 13. Now we know that 2 inverse 2 cancel, like it becomes 1, so this is going to be just x. X is less than x plus 1 divided by 2. This is what y value is, right? This is what we have right now. So x is less than this one. We prove this one. Now we have to see, we have to prove this x plus 1 divided by 2 is greater than 0. So first let's go ahead and show that one. Okay, let's continue here. So first we say y is equal to x plus 1 divided by 2 belongs to 0 to 1. We have to show it's in between that. And first we have to show this is greater than 0. So 0 is less than x plus 1 divided by 2. Now we know that 0 is greater than x. Therefore if we add 1 to that, plus 1, x plus 1, as we did before, this is axiom number 12. Whenever you have 0 less than x, if you add whatever to that, it should be the same. If you add whatever to both sides, it should be the same by axiom number 12. Now we have did this one. Now 0 plus 1 is 1 and less than x plus 1, and also 0 is less than, we know that 0 is less than 1, and x plus 1 is we have 1 is less than x plus 1. So by axiom number 11, that's transitivity, it says if you have this comparison, you can directly say 0 is less than x plus 1. 0 is less than x plus 1 by axiom number 11. Okay, Now the next thing is, now again we are going to use the axiom number 13. We know that 2 inverse is greater than 0, or if you want to write in this way, let's try this one. We have 2 inverse is less than, like 2 inverse is greater than 0 already here, and we have brought this one, 0 is less than x plus 1. So here we had to put 0 is less than x plus 1. So first we multiply this one, 2 power minus 1. Let's get rid of this one, let's use a different color. And 2 inverse times 0. 2 inverse times 0 is less than 2 inverse times x plus 1. 2 inverse times x plus 1. And 2 inverse times 0 is equal to 0 by proposition number 1. And 2 inverse times x plus 1, that's going to be just x plus 1 divided by 2. Okay. Now we proved that x plus 1 divided by 2 is greater than 0. Now we have to prove x plus 1 divided by 2 is less than 1, because we have to show this value belongs to, like it stays in between these two, 0 and 1. Okay. So these are the important things you have to notice. Now let's get rid of some of these things because we need some space. Let's get rid of these things. Okay, let's continue here. So we proved 0 is less than x plus 1. Now we have to prove x plus 1 divided by 2 is less than 1, because we have to show we prove x plus 1 divided by 2 is greater than, like we proved that one right here, x plus 1 divided by 2 is greater than x and also greater than 0. Now we have to prove less than 1. That's what we are going to do. We know that since x is less than 1, if you add 1 to both sides, x plus 1, 1 plus 1 by axiom number 12, this should be the same. If x is less than 1, if you add 1 to both sides, it should be the same, right? So from this one we know that x plus 1 is less than 2, and again we are going to use the axiom number 13. 2 inverse is greater than 0, so we are going to use axiom number 13. If you remember, we have to put it like this: 2 inverse, and whatever the less comes here, x plus 1 less than 2. First we multiply like this. Okay, that one is 2 inverse times x plus 1 is less than 2 times 2 inverse. 2 times 2 inverse, that is this one. So this is axiom number 13. And if you simplify this one, this is going to be x plus 1 divided by 2 is less than 1. And that's what we want to prove. X plus 1 divided by 2 is less than 1. And finally we proved everything, right? And if you want to get this one back, x is less than 1, you can always try to prove that x plus 1 is less than 2, therefore x is less than 1. And that's it. That's how you prove a there exists type of question. I hope this helps. Thanks for watching, and don't forget to subscribe. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. See you next time.